So this is going to be an introductory video on animation nodes, which is something I use a lot in my videos on my main channel. And I think it's probably the most important aspect of my animations. So basically, hopefully you've installed animation nodes at this point and you don't need to know anything about it. But what I'm going to do is I'm just going to work through an example. And along the way, I'm going to try to take the steps that we do to achieve it and explain the intuition of A, what animation nodes is thinking, and B, how we need to think to apply these nodes and animation nodes to achieve this result. So first things first is we're going to go ahead and we're going to change one of these windows to our animation nodes editor. And we're going to create a new node tree. So first thing you need to keep in mind is don't get overwhelmed by everything that's going to pop up here. Sure, it looks like a lot, but they kind of do the same thing. And I don't know, once you get used to it, this honestly, it feels like it's not enough. Like I've used every single one of these. So at some point, this doesn't even become enough. So don't worry about that. So what we need to do is we need to conceptualize how we're going to achieve this effect right here. And basically how we achieve this is by we take a certain element or an object like this, we duplicate it a bunch of times, and then we tell it to meander or travel around aimlessly in a certain area. And that's what we're going to try to do now. So first things first is this is going to be the object we duplicate. So I'm just going to make it look a little bit sexier so we don't just have a really boring cube. And we'll probably change it to a metaball later, but we'll worry about that later. So first things first is we need to tell animation nodes that, hey, we want to create locations or vectors in space. And a vector is basically it's a 3-element component that is made up of an X, Y, and Z component, and it defines any point in space. I mean, that's what this is right here. So this is a vector 8.900. So in order to do that, we're going to go ahead and we're going to choose matrix and distribute. So a matrix is basically as long of an element as you want that can contain as many vectors as you want. So you can imagine like a large matrix composed of as many vectors as there's going to be. And what we're telling it to do is we're saying, hey, I want you to create, so they exist right now, you just can't, we're not using them. I want you to create vectors or locations in space that I'm going to, do something with in the future. So with this right here saying we're doing a grid shape, you can distribute them in whatever shape you want, but we're going to do a simple grid, and we want there to be 3 divisions. So you can kind of think of this as like an array modifier. So 3 divisions on the x-axis, 3 on the y-axis, and we're going to do 3 on the z-axis. So you get a nice 3-cubed or 27 vectors throughout space. Now these do exist. And if we click here, we can go to viewer, we can do vectors, and we can see it's produced these points. We haven't done anything with these points, but they exist. So now what we're going to do is we're going to say, hey, at every single one of those points, I want to pop this object. That also means we need to have 27 versions of this object. So what we're going to do is we're going to go into the object menu and we're going to choose an instancer, which is basically taking a base instance of an object and duplicating it a certain amount of time. So now what you want to do is select the object that you want to duplicate, and we're going to go ahead and select this gray eyedropper here, and basically saying that's the guy we're going to duplicate a bunch of times, and this is the number of times. So we know that there's 27 different vectors or locations in space, so we could manually type out 27. But that's not what you use animation nodes for. You do everything automated. So as I mentioned earlier, we have a list of vectors here, and we can see that there's 27 elements in this list. So what we can do is we can go to the list subsection and find a get length node. So this is basically saying if I plug in a list, it's going to tell me how many elements are in that list. So now if we click viewer, you can see that there's 27 in that list. So we're basically saying I want as many locations that exist in space, I want that many cubes. So I can change this at will, and we can see that the number of instances or elements increases, and so too does the number of cubes. As you can see here, now we have a ton of different cubes. So we're going to go back to our 3x3x3. So now we have 27 cubes existing on the origin. So now we have our cubes, we need to tell them to, hey, go to these locations. So now we have two lists. We've got a vectors list and we've got an objects list, and we need to find some way to combine them. So I mean, just to show you so you can understand more of what's happening, you can see here there's a list of 27 different objects. So what we're going to do is we're going to go ahead and tell them to all, we're going to assign one element from a vector list to one element from the object list together. And we're going to use a transforms output. So now what we're going to do is we're going to take these objects right here. So remember, this is the object list. That's these guys right here. I'm going to say, I want you guys to all move to this area. And bada bing, bada boom, you get that. So what's happening here is we're using a transforms output node. This is basically saying we're going to output a transformation onto a specific object. In this scenario, we're using a list of objects. Now, whenever you have two lists that plug into a node, what it'll try to do, and it can't always do this, but it will try to pair up one element from one list to one element of the other list. So therefore, you have one object from one list being paired to one vector from one list. And since they both have 27, you've got a nice symmetry. You can, of course, change this if you want. So I could make this like this, and it'll just assign it as it can. As you can see, it'll assign what it can do. So I'm going to pause here and we'll start again. All right, so now that we have our cubes distributed within space, we need to start telling them to move about. Now again, you could hand animate every single one, but luckily Animation Nodes has a built-in function called the wiggle function, which is kind of like a noise, but it's a smooth noise function. So we're going to go ahead and open up Vector submenu and choose the wiggle node. So this is basically saying, I'm going to generate vectors, so I can go ahead and make sure we see what's happening here. I'm going to generate vectors, and as it evolves, it's going to slowly change around, so it's not going to have jumps. It's a very smooth noise function through three-dimensional space. And I want each one of these guys to move around with this noise vector. So what I could do is I can go ahead and plug in my wiggle vector into the locations, except then all of them will be sharing this output. As you see here, all 27 of them will stack up. So now we have an issue where I want to no longer deal with a list. I want to deal with each individual object within my list. So how do we do that? Well, now what we're going to do is we're going to do the opposite of combining lists. We're going to break apart a list into its individual elements by using, by the way, I'm pressing W. It's not showing up here for some reason. Whatever. I'm pressing W to get this menu here. And we're going to choose loop through, and then the output is objects. So now what we had was a list of objects. Now we can treat each individual element as if it's on its own. And then what we're going to go ahead and do is also add a vector list. Vector. So now remember, we used to treat like this node right here treated the list as one element paired with another element. So now we're looking at each individual element, and we're going to treat each one of them in a specific manner. So let's just pretend, let's ignore that all these exist, and now we can just pretend like only one of these exists. So let's just say, what do we want this guy to do? Well, we want this guy to wiggle. And the thing with wiggle, though, is this vector that it produces here is always based around the origin. So I want to take this location and add in to this random vector. So it will still, it'll rotate around this particular location here. That'll probably make a little more sense here in a second. So what I'm going to go ahead and do is I'm going to use a vector math node. And what's going to happen here is I'm going to take its location, which is right here, vector. That's the location of this cube. And remember, this is all the cubes, but it's more easy just to think about a single cube. So I'm going to take the location of this cube right here, and I want to add my wiggle to it. So now, as the wiggle evolves, this cube is going to move around, and it's going to move around centered around this particular origin right here. So then what we have to do is we have to go to an object, transforms output, and we have to say, hey, I need you to use this new vector result to wiggle around. And so we plug in our object. So this guy is going to be the guy who wiggles, and then we can put in our result here. And now the problem with this, though, is that they all share the same wiggle. So you can see here they all wiggle together. And we want them to all meander. Now, luckily, wiggle isn't completely random. What it does, it's assigned a seed. And the seed, as you see, as I change it, it kind of randomizes how the pattern, evolves through time. So what we can do is that, remember, this is a list. And this list is composed of elements. So if I take that specific location in the list or the index of that object within the list, I can then use that to define the seed. And once I do that, now you're going to get each one has its own individual wiggle. And then as we have it evolve, we can see that they all meander about on their own. Very cool. So now that I've got all these guys meandering on their own, I want them to do it without me having to manually move it around like that. So what we can do, obviously, is I'm going to make this thing increase as time increases or as the frame moves. So we can go to animation and time info. And you can see here, this frame right here represents the frame that we're on. So right now we're on the first frame. So I can go ahead and plug that into evolution. And then if I press space, as the frame increases, these guys move around. And now we're starting to get some cool animation effects. So we're about, 40% of the way done. And what I want to do now is I want these guys to follow an empty. So if I want to move them around through space, I don't have to I don't even know how I would do that without this. So what I'm going to do is I'm going to go ahead and put an empty in the middle right here. So make a nice little sphere, make it kind of big. And basically what I'm going to do is I'm going to say, hey, wherever you are in space, I also want you to make sure you're following this empty. So if this empty moves 3 to the left, then each one of these cubes also moves 3 to the left. So I can just move this around without any kind of hassle. So what I'm going to go ahead and do is go to Object, Transforms, Input. And you're going to get these confused don't worry, it's not a big deal. But input is basically saying I want to take the transformations and input it into my function. And output is I'm taking the information from my function and outputting it to an object. So we're going to go ahead and select the empty. And we're going to do another vector math here. So now we're going to take the result from the wiggle, is this guy. And I want to add the location of my empty. So right now it's at 0, 0, 0. So nothing's going to happen when I plug this in to the location. However, if I start moving this around now, they all move along with this. So if I want to, create a cool movement or whatever, it's very simple now and I don't have to worry about it. So again, this is another thing where animation nodes is super powerful. Traditionally, you would have to go through here and select every single one and then move it around. You can't do it with animation nodes on, but then move it around like that. And it's a hassle. Whereas this scenario, I can just do this. And they're not parented either, so I don't have to worry about, size affecting it or anything. So now that I've got this, the next thing we want to do is I want these guys to, the cubes here, to shrink and expand as they get closer and further away from the center, and which happens to conveniently be my empty here. So what I'm going to go ahead and do is I'm going to make that a product of the distance. So I want when our cubes get further from the center to shrink, and when they get closer to get bigger. So what I'm going to go ahead and do is go into vector, and again, all of the magic of animation nodes is basically all these functions here. So you kind of have to go through and figure out what they do. But once you understand what they do, it's pretty simple to use them in your node tree. So what distance does is it takes 2 points in space and it tells you how far apart they are. So what I'm going to do is I'm going to take my empty. So right here, I'm going to click my empty, the location of my empty. Sorry, I'm not a very neat person when it comes to trees. And then I'm going to take the location from the wiggle right here. So again, remember, we're still working in the loop, so you can still think of each individual cube. You don't have to think of it as lists anymore. And then I want that distance, so you can see here, the distance, it always shows the last element in the list. So the distance, I want that to be the size. So we're gonna go ahead here and we're gonna enable size transformations. And then we're gonna plug this into our scale. Now the scale is a vector. So traditionally you would have to turn this into a vector, but again, animation nodes does everything for you. So boop, now there you go. So the problem with this is that as it's inverse to what we want. As things get far away, the distance increases and therefore the scale increases. And we want the inverse of that. So how do we do that? Well, you could do some sort of math, but there's a really cool node called the map range node. And basically, we'll explain how this works as we work with it. So what I wanted to do is basically say I want to define a distance from the sphere that they can go as far I want to define a distance from the empty. And if it goes past that distance, it'll become, it'll shrink to 0 and it'll disappear. And if it gets really close to the center, it'll become its normal size. So I need to inverse this. So we're going to set the minimum to how far away I want them to be before they become 0. So we'll set that to 5, since we can see that the amplitude over here is 5 for our vector wiggle. And then I'm going to set the input to 0 so they can get as close to the middle as they want. And then I'm going to go ahead and you can just leave everything you want. So now when we play it, you can see as things get closer to the middle, they get bigger, and as they get farther away, they get smaller. What I want to do, though, is I'm going to change the interpolation. Right now it's linear. So what I'm going to do is I'm going to give it a curved function so that when it's close, it gets bigger faster, and then when it gets further away, it gets smaller faster, I guess. So now we do this. So now you got a little bit more larger sized, and you can see they shrink really fast when they get out there. There we go. We're about 70-80% of the way done. So now the last thing to do is we need to add some rotation, because now they kind of look boring. So luckily, just like with our vectors, there is an Euler wiggle. So I'm going to go ahead and enable our rotation on our object transforms output. So now if you can do that here, because you can see they all rotate. So now what I'm going to do is I'm going to create a Euler wiggle. And just like with our vector wiggle, I'm going to assign the index to the seed. I'm going to assign the frame to the evolution, and then you just plug it in. Now actually then I'm going to create this to 360 degrees. So we get some pretty crazy rotation. Now, we've basically got the effect that we're looking for. And the cool thing about this is you can move it around wherever you need it. And now this is where animation nodes get super powerful. So let's say I'm going to go ahead and save this just so we need that. Globby anim. There we go. So this is where animation nodes get super powerful, because if you did this by hand and suddenly you're like, I shouldn't have done a cube. Well, then you'd have to go through and change the cube unless you synced up the mesh data, but don't worry about that. So what we can do is we can go ahead and just change things out. So let's say we want more cubes. Well, then we can just simply make this 4x4. And actually, before I do that, we're already at 22 milliseconds. I'm going to go ahead and make it so it only executes when things change, not always. And I'll explain in a future video why that's important. So now I can set this to 4, and now we've got more objects to deal with. So now we got a little bit more, it just looks more interesting. So without having to manually add things, I can just do that, and animation nodes will update on its own. And let's say I didn't want a cube, I wanted this sphere. So now I can click my instancer, click on the sphere, and now we got a bunch of spheres, and they all do what we wanted them to do, but we instantly change the object without having to do any kind of work. And then finally, let's get the coolest thing that we can do, which is creating a metaball. So now, if you've worked with metaballs, you can see where this is going to go, and how interesting this is going to be is that the metaball is going to stick with other balls that are nearby, and you'll get this really cool, I don't know, Nickelodeon-looking globular mess. So we're going to go ahead and click the ball. I drop that in, and oh no, something went wrong. What happened is the way the object instancer produces its instanced object. Basically what it does is it assigns a random name to all of its new objects. And the metaball system in Blender needs all of the children of the metaball system to start with the name of the metaball. So it could be Imball, or I'm just going to go ahead and name him Greg. So now what we have to do is we just go here and we click copy full object. That way it'll copy the name and then it'll append it with a 0.00 whatever. So we click, and then there you go. Now we've got our little globular thing, and you can see it looks it looks really cool. And then I don't know, it's just up to your imagination. You can assign a really cool you could assign a cool material. You can make it look really ethereal. And another thing that's really cool is if I unparent this following motion, if I go ahead down here, and I believe it's this guy, I pop him off. Now this is sort of like a search ball. So as I move it away, they disappear. And as I bring them in, they glow up. And I don't know, you can have like this idea where there's some sort of entity within a room, and you have a magic flashlight, and you shine the flashlight, and you're like, oh my God, what is that? So that's the first example. And hopefully you get sort of an idea of what's important is how lists are treated, and then how animation nodes thinks about executing specific I don't know, executions.